be some. I've been told that there's going to be some live demo, live coding demo, as well as some background and rationale for this. So I want to leave plenty of time for that. We'll follow our usual protocol of this speaker will present for maybe 40, 45 minutes. Please do feel free to leave questions in the chat on Zoom during the presentation. And if it seems urgent, we'll interrupt and pose the question. Otherwise, the chat can be the basis for our some discussion towards the end of the hour. One other note, since we are going to be looking at some code during the presentation, I'll just note, I'll tell you about a feature of Zoom that I just learned about moments ago, which is if you look up at the top of your Zoom, there should be a little box that says Mikkel Vembye's screen. If you click on the little dot, dot, dot to the right of that box, you can control the zoom ratio of the shared screen. So if you wanted to, if you're having trouble reading the code at some point and want to zoom in on it, you can zoom to 100 or 200% magnification. It's kind of a nice feature. Cool. Um, so with that, I will pass it over to Mikkel. Take it away.
And yeah, first of all, can you hear me? And the sound is good? Yes, great. And James, thank you for the very kind words. I would say it's the opposite way around. I'm very pleased that I had the opportunity to work with you. But anyways, thank you for saying such kind words. Um, yeah, and also thank you for the invitation. I'm very glad that I get the opportunity to present this work because I think it has the potential to be very important for our community, and I think it's very important to show it. I actually feel the more I work with this, the more obliged I actually feel with I feel obliged to sort of share this knowledge with you because it's very powerful and you can save a lot of time in a reliable manner. And as some of you might know, some of the one of you that know me, um, I'm a man of many words, so I could actually speak for many hours about this. So, but to keep it short, I have tried to set up what are the main goals of my presentation. And it's because I will also today do a live demo of our new software, and that could take some time, but I would really try to see if I can I can stay on time. But the main goal, I think, or the main goal of the presentation today is to sort of give you a practical understanding of what do we mean when we talk about doing title and abstract screening with GPT API models, because this is an entirely new way of doing title and abstract screening compared to human screening. So I really want to give you uh, an insight into what do we actually mean, how do we set it up, and I really also want to give you an impression of how relatively simple how relatively simple it is to set up, but also how powerful it is. And to be entirely honest with you, I must say that I've really tried for a long time to temper my excitement about this approach for various reasons. In our society, there are some people that are very much against the use of OpenAI's GPT models and these things. And for a long time, I have really I've looked at it and think, what am I not seeing? Is it really that good? But I think it's very hard for me now to temper that excitement anymore, I must say. I think what I see at least, and this is a very, very powerful message. And I actually get a little bit dizzy when I'm working with it, to be honest with you, because seeing these TBT models doing screenings in just a couple of hours, some screenings that has taken us more than a year to complete, I really get a little bit dizzy about it. But I would also say I think it has the potential to change the way we do child and abstract screening, but we really need it to come out there and get tested so we also can get a better understanding of the limitations of this approach. And then the last point I really want to make today is to discuss how you actually can quality assess such screenings as the ones that I present today. And I would just say all material behind the presentation, you can find it here at my GitHub page. And the work that I present today is also joint work with three of my Viva colleagues, Julian Christensen, Anja Mølgaard, and Frederikke Skøtt. And we have a paper, that's not been published yet. It is under peer review, but there is a preprint at OSF that you can also read, and where we go into more details, more technical details behind what we are doing here. So just to sort of set the scene for this presentation, I would try to start to ask the more fundamental question: why do we actually want AI for screening and systematic reviews in general? And in my opinion, there is at least two groups of reasons for why we would like to have AI models doing some kind of screening for us, or at least help us. And the first line belongs to the quality reasons. A lot of research have shown that human screeners, if you do single human screening, it's very common that you will overlook relevant studies, also substantial and a substantial amount of relevant studies. And therefore, the state of the art is to do or is to conduct a human double screening. However, this is very costly, and many research groups, they cannot afford doing double screening. At least this is very common in medicine, that you see a lot of single screen reviews. And we know that there is a high risk of overlooking relevant studies. Again, another reason is so at least in my research group, it's very common that when we do our database searches, we narrow them or limit them so much that they yell a number that they yell a number of studies that has a manageable size for us to screen, and that again increases the risk of overlooking relevant studies. And overlooking relevant studies at this stage of the review can be consequential if the undetected studies are systematically different from the detected ones. So we really want to find all relevant studies. And then again, we have all the resource reasons. Title and abstract screening on large scale reviews is very time consuming. And I mean, I think in my research group where we do Canberra reviews, we spend on average 3 to 5 months at least on this project. And I would also say even more in large review, up to a year, actually, where we have students screening our title and abstracts. And it's very tedious. It's manual work, and it can be very hard to finish. And I haven't met any student that said, "Oh, this is just very great to do." It's very hard to do actually because it's so tedious. And we also experience in our research group that even some reviews are not reviewable, if that's an English word, but you cannot really do it because you know if you should make a reliable database search, it will simply yield too many references for you to screen, and we don't have resources for that. And again, the latter problem here will just increase over time as we will see more studies coming into the databases. So at some point, we really need to have this type of screening automated in some way. Uh, so just to get a little bit more concrete, what have we actually tested and developed? So yeah, to be concrete, we have tested the use of OpenAI's GPT API models to screen title and abstract. And every time I present this for someone, they instantly think of ChatGPT. But this is something different, and you will also see that in a moment when I sort of give the live demo of the AI screener and the R package that we have developed. Uh, but these models are a little different. The models that we draw upon are not someone that you can speak with. They just sort of end the sentence that you give them. You can say, and they are a little different from the ChatGPT models. And there's also research indicating that these models behave quite differently. Um, and yeah, in the paper that we have written, we also do some experiments that I can come back to later on in the presentation. But we actually show that the GPT model, in our research, we can show that GPT models, they perform at least on par, and they actually, in some cases, even better than human screeners, and even in complex reviews. And I will come back to that. And then, since we think this is quite a powerful way of doing screenings, I might say, I have developed the AI screener, to sort of ease the use of this screening approach. And Again, so far in our research group, I think we have used this screening approach in 6 or 7 reviews, and we haven't yet encountered that we have not been able to use it in a reliable way. Um, so at some point, I'm also looking very much forward to seeing a case where this is not working, because that will really gives us that can really teach us something about what are the limitations of this approach. But okay, based on our experience, we suggest in the paper that under various scenarios, and if you do some quality testing that I will come back to later on in the presentation, we actually suggest that GPT API models can actually function as full second screeners in state-of-the-art reviews. And that's what we will talk about today. Um, Before I will go into the AI screener and give you sort of the practical understanding of what do I mean by screening with GPT API models, I would just like to sort of take this question up right away. Why actually use GPT API models and not just use ChatGPT? Because I get this question quite often. There are some advantages by using the GPT API models, and one of them, at least that I see, is that you avoid a lot of copy paste procedures. So when we began looking into this, we and my colleague Julian, he began by using ChatGPT. So he made a prompt and then he copy pasted 20 or 40 Thailand abstracts below that prompt. And for the first 5 and 10 Thailand abstracts, the ChatGPT actually made quite reasonable decisions and made correct decisions. But then suddenly it began to hallucinate. It forgot suddenly what we have told it in the prompt, that it made its own inclusion criteria, you can say. But this is quite easy to bypass this kind of model hallucination, and I can show you that in a minute how we do that when we sort of screen through the API models. Again, it also makes it very easy to test differences between models and prompts and other kinds of features, request body features from the API. And then you can screen an incredibly large amount of references in very short time. So, I mean, if you have access to a sufficiently large computer or server or whatever, you can actually screen up to 3,000 Thailand abstracts per minute. That's quite crazy. I know it's not all about speed. It's also, of course, about accuracy, but you will also see that it can be actually very accurate. And you can do multiple identical screenings. So, and then, for instance, say you do 10 identical screenings, and then you sort of include Thailand abstract based on how many times they have been included across those screenings. And that's very easy to do. And again, here you can draw on the GPT 4 Mini, and it's actually cheaper than subscribing to ChatGPT Plus. And with one prompt, let's say a prompt that is about 400 words, you can screen approximately 35,000 references for $1.50 or something like that. So it's very cheap. And then again, some research actually indicate that the GPT API models have better screening behaviors than the ChatGPT models. But it's not something I have tested so far. All right, but just to give you this practical understanding and really show you what are we talking about, I will jump to the code now. And I will just say in the package that was just released last Friday on CRAN, we have also this vignette where you can sort of find more detailed information about everything I say today. Um, all right, but yeah, so again, it might be a little odd spending so much time on the coding part, but I just really want to give people the impression of how easy it is, because it's not because you have to do a lot of coding. It's actually just requires few relatively simple steps. So, and I will try to go through them and also just show how easy it is. So of course you would like to first of all install the AI screener, and then you would like to install a bunch of other packages. But the two main packages that are very important are three main packages is the AI screener and the route tools package. Because the route tool package is actually the package that allows us to do this screening because it enabled us to convert our risk files into data frames. That's very, very nice. It's a very nice feature, and that's the main engine and main reason why we can do it. At least I had to do more coding if I didn't have this package, I would say, because then I had to develop that function that enabled me to convert risk files into a data frame or table, and then a bunch of other. And the future package is also very nice. And that's another reason why we actually would like to use the GPT API model is that we can do stuff in parallel. So we can really speed up the process here. Uh, and yeah, we have some options. Don't, that's just something I like. So the first thing is I will just see here, say that our librarian now has given us our risk file data. So we have our risk files, and we have downloaded these risk files from our review software. In this case, I have downloaded it from the Epi reviewer. We have done some screening, and now we know that we have some references that should be excluded, and we have some records that should be included. And the first thing you need to ensure is that you sort of have the right working directory pointing to the folder where you have your risk files. So the next thing is now we can really draw in the route tools package, and we can load in all our irrelevant studies, all the studies that we have screened that we have considered to be irrelevant for the given review. And this review that we are screening for now is a review about the effects of it's a Campbell review about the effects of the French prevention program on anxiety symptoms in children and adolescents. So I will also be entirely honest with you. This is a very simple case. Mostly, I use it mostly to do the proof of concept, and most of you will experience that you are working with much more complicated stuff. But I will come back to that later on. This is just to give you a sort of a case where you can really see that it works very well. And then you now have this data set, and you can see you have 2,765 Thailand abstracts that you would like to screen, and you have you have title, you have a lot of information, and you have the abstract here and other stuff, which it's not really necessary. But in the paper, we suggest, so how do we decide when it's appropriate to use GPT API models in a review? We suggest that you sort of make a test data set. So where you sort of know what is the correct answer. So this is the example that I give today is more for illustration purposes. So don't really draw any hard inferences from this because we suggest making a little bit larger test data set than what I'm showing today. But now we have all the excluded references, and we randomly sample 100 of those. So now we have like again, and we just take out the variables that sort of are relevant for us, and in this case, it's the Thailand abstract. And since we know from our screening that these should be excluded, we make this human code variable saying 0, indicating that they should be excluded. We again do the same for the relevant studies. And again, this is for illustration purposes only, because at this point of a review, you would probably not have you would not have knowledge of that many relevant studies that you would be able to sort of random sample from the relevant studies. But this is again, just to show the working here. So now we have made a data set with all the included, a random sample with all the included references, and we can make our test data set. So now we have a test data set, we have author title, and we also have an Epi ID because we retrieve it from Epi. And it has this, I just made this study ID because there is one record without an Epi ID. So just to have a study ID with no missings, I just made this study ID here, and you have title and abstract for all this, and you can see it has this setup. So the first 100, they are irrelevant, and the last 50 is relevant. So now you have the test data set. That's the first part of it. Now we go to the prompt. So you can work with multiple prompts. You could write more than one prompt, but in this case, one prompt is enough. I will show you. But basically, and that's the crazy thing. I wrote this prompt in less than a minute. I just took the protocol for this camera review, and I just put in what is the main topic, a little bit of explanation about what the French program is, and this might be superficial because we are working here with trained models, so they might already know the concept of the French program. Um, and then we tell it a little bit about that we are exclusively looking at this topic and searching for studies with a treatment comparison group, and we give it our two main inclusion criteria, which is this a French preventive program, and um, is the study estimating an effect between a treatment control / comparison group, right? So now you have the prompt, and you just make that as a string. And then the next part, and because we are recording this, presentation, I cannot really show you these functionalities because then I would compromise my API key, which I'm not allowed to. So, but the basic thing is you go into when you this might be some of the stuff that can make some trouble, but you actually just go in to your OpenAI profile, if it works here, and then you generate the key, store it a safe place, and then and then you can use this function set API key. You cannot compromise it because it's closed here. And then what this set API key function from the AI screener does is that it adds your API key as an R environment variable, and all the AI screener functions that call the server models, they draw on this get API key, so it sort of retrieves the API from the R environment. So you actually never have to show your API key, and you actually never have to worry about it really. Especially if you do it what I call the permanent way, where you actually go into you edit your R environment and then you add it as is also described in the vignette. You add it just directly into your R environment and you restart R. Now you actually, unless you, of course, download a new version of R or get a new computer, you have to do this again. But otherwise, you actually never have to think about your API key again. Yeah. So now we have the test data. We actually have the prompt. This is actually not necessary. You don't have to inspect your model access, but just to increase, just to sort of get the maximum out of your access to the model, you can use this rate limit per minute function to sort of get an overview of how much access do you have to a given model. And in the AI screener package, we have this data set with model prices, but here you also have a variable character vector with all the models that are available that you can call within the AI screener functions. So here you could, for instance, just check what do I actually have access to. Let's see how fast it is when we are on Zoom. It allows me to take a sip of water here. All right. So now here you see, okay, actually there's a model that even though I'm a top 10 user or whatever they call me, I have not access to this GPT-4 something model, but I can see, okay, what I'm actually having access to here. And what I will focus on today is the GPT-4o mini model, which I consider to be quite crazy because you have so much access to the server. This is an amount you can send 30,000 requests per minute, and each request can be of a size around 8,000 words. That's quite a lot. So, and again, it's not about speed and size or everything, but it's also quite accurate. So I really like the GPT-4 Mini, and I always think you should try that out before you're testing the GPT-4 model, which is 200 times more expensive than the GPT-4 Mini. 4.0 Mini. Yeah, sorry about this speaking here. All right, well, now you're actually ready to do the first screen. That's basically it. You need your test data set. You need to make a prompt. You don't have to specify the study ID, but this will just be done automatically if you don't specify it. You have to tell what is the name of the variable containing your titles and the abstract, and then you have to. This is actually the default. GPT 4.0 Mini is the default, so actually you don't have to specify it. But again, you could specify many models here. How many reps, that's how many times would you run a screening. I will come back to that in just a minute. And then how many requests per minute do you have access to? And now you can actually just run the screening. Let's see how slow it is when we're on Zoom, but it allows me to get something to drink. Uh, So what the screen AI, the tap screen function will do is also tell you what will the price approximately be. So screening these 150 Thailand abstract will cost almost 0.0 what is it, 0.17 cent or whatever it is. It's very cheap. And then you get, because we do things in parallel here, you also can see the progress bar. You can follow the progress here. Um, and yeah, it shouldn't take much time. So now we have actually run the first screening. We have screened 150 studies. And if you just sort of print out the object, you will see that it just gives you a text because it's basically a list that contains well, that contains the price data. So you can see what was the actual price of your screening, and then you have this answer data. And that's what we will go into now. So you can see now we actually have the same data set, title and abstract. We have the prompt that we used, the model that we used. How many times did we want the how many screenings did we want, and everything else. And you can see here that is the question that we have sent to the API model. That is basically the prompt that is glued together with the title and the abstract, and then also glued together with something called a function call. But what you see here now is that we get the decision. We get the decision from the GPT models. And as we know, all the zeros are in the beginning and all the ones are in the end. You can see it did it, just looking over it quite fast, it did quite well. But we also want to access this more formally. So you can use this screen analyzer from the AI screener because we really want to sort of get a more formal assessment of whether it did good. So here you can get more detailed results if you set the key results to false, then you also get some inter-rater reliability and stuff like that. But these are quite sensitive to imbalanced data, so a little bit harder to interpret. But anyways, you can get them as well. Here I just get sort of what I call the key results, what I'm interested in, and what our paper also concerns is the recall and the specificity. And the recall measure is basically just the model's ability to correctly identify relevant studies, and the specificity is the model's ability to to correctly recognize irrelevant studies. So this basically says approximately that it finds 9 out of the 10 relevant studies that were considered relevant by humans in this case. And again, 96% of it excludes 96% of the studies that were excluded by the humans as well. And we will come back to this. This is quite high measures. But as with humans, there are a little pile, there will always be this little pile of title and abstract that can be very hard to assess whether they are relevant or irrelevant. And so if you run this model again, the GPT, especially when you work with these cheaper models, there is a little bit of uncertainty. So if I ran this again, you could see a new recall quite close, but there are these studies that where the model sort of changes decisions over the screenings. So what we suggest is instead that you run multiple screenings. For example, you say we run 10 screenings and then we decide whether we should include a title and abstract across these 10 screenings. It will take a couple of minutes to do so. So I have cheated from home. But again, you just need to set reps to 10. Then you will do 10 identical screenings. And we load that. And now you get a new, so if you print this, you get a new text because this object not just contains the answer data. So the answer data, if we should look at that, would, whoop, the answer data would look like this, where you have, so every study is sort of appearing 10 times in a row because that was what we asked for. But then you now also have this aggregated data where you, oh, sorry, um, where you sort of have made a decision of whether it should be included based on the probability across these 10 screenings. And the default is that if it has been included in at least 4 out of 10 screenings, it will be included. So we could again analyze this and we will see what was actually the first. It's actually the same. It's not changing much, but again, we could, something with this code, we could sort of, we can get an impression of what if we say, just we will include all title and abstracts if it has been included in at least 1 out of these 10 screenings. Then we can actually increase, in this case, the recall up to, yeah, 96%. It's actually meaning that it's only overlooking 2 studies considered relevant by the humans. And we will come back to that in a moment. So I really think in this case, I would say, if I should use it, I would say something like, okay, we use 10 screenings and we decide whether a title and abstract should be included if it has been included in 1 out of these 10 screenings, just to be sure that we are not overlooking anything. Then the next step, I will speed up here, I can see, but the next step is sort of to and this is not something we have written much about, but something I really think is very important is we really would like to understand why did the human and the GPT model disagree. So we make a data set that just contains all the studies where we included it and where across all screenings were excluded. And then again, we then just run the screening, and now we actually want to have a detailed description because that's another function call that we have built, a function call that forces the model to give a detailed description about its decision. So we could run that again. Let's see. In this case, you will also get this message that you should just be aware that when you want to get detailed responses, we cannot approximate the price exactly. So it will get a little bit more expensive, but we cannot really tell you how much because it depends so much on the length of the response from the GPT model. Hopefully it will stop at some point. Otherwise, we will cheat. All right, we don't have to wait for that. We just jump out. I am prepared for stuff like that. So now we actually have this result. Interest. And we have the aggregated data. Let's view it so we can see. So now we had these 2 studies that was excluded by DBT but included by humans, and they are in the rescreening, they are still excluded, and now you actually also get an description why is it actually excluded. You get it here, and the reason why it's the longest answer in the aggregated data is that in the answer data you have sort of 10 descriptions of the exclusion, and here we just take the longest, which we then assume to be the most detailed. All right, and then I will eventually add this report function to the AI screener, but I haven't done it yet. But I will share it here with you so you can use it. And now you could actually get a report. And this report I actually think is very important because I think you should enclose this report with your screening if you are using this approach. And I will tell you why. So here you can, for instance, make a Word document if it's coming up somewhere. Where is it? There we go. Why can I see it? Right? There we go. Okay, so now you get a report included by humans, executed by GPT. And here you sort of see the GPT and you have the title, the abstract, and you now see the answer from GPT. And in this case, it's actually reasonable why it has excluded it. I also know that this study is not going the entire way in the review, so it's actually a correct decision that GPT makes. But here it says that it was informed by a universal program, the Fun Friends, but it was not the Fun Friends. And that's what GPT sort of says here in the description. And again, the other study is this Friends Parent project, but we are looking at children and adolescents. So it correctly recognized that this is about parents and it's not about the children and adolescents, and therefore it excludes the study. And when I see stuff like that, it's very new to me because when I have been investigating this, I'm always going into this saying that humans are right, DBT are wrong. But it's actually, the more I work with it, it's more often that I think the human has been over-inclusive, and I really understand why DBT actually made the decision, if we can use that word, about such models. But that's very important, I think, that you scrutinize what are the reasons for what are driving the recall, so to speak. Is it that we are just over-inclusive, or is it actually that DBT are making wrong decisions? And then, so in these kind of reports, you can here add a comment. Uh, what do you think about it? Is it just a pure error, or is it us being too over-inclusive? Because if you enclose such reports with your screening, it will be much easier for peer reviewers also to see, to get an understanding of what is driving your recall, so to speak. Yeah. All right, and I've actually almost done, but then the last functionality in the AI screener that I will highlight is that now we have decided, we can see in our test data set that it's very appropriate to use the GPT API model, and then we can sort of make a data set with all our title and abstracts, and we can sort of approximate the price of the simple screening. And when I say a simple screening, I mean screenings where you get a 0, a 1 or 1.1 back from the API model. And the 1.1, just to talk about that, we have made these function calls so that we try to make the DBT model over-inclusive. That means that we have in our function call stated that if it's uncertain or it doesn't think it has enough information to make a reliable decision, it should just include it. And that's what 1.1 actually indicates. And yeah, you can see if for these running 10 screenings with these 2,862 references, it would cost you $3. So it's quite cheap actually to do so. Yeah, but that was enough about the coding. Now I hope you have a more a more practical understanding of what I'm talking about here. So I mean, this is also a very simple case. And I have to be honest about that. It's a very simple review with simple inclusion criteria, and it's the recall measures are very high. And you will not necessarily see that when you work with more complex reviews, with more that has more inclusion criteria, more complex inclusion criteria. So the big question here is, how do we actually assess whether it's all right to use this kind of screening approach? Um, and to sort of answer that, we have tried to develop this benchmark scheme where we have mapped typical human screener performances from 22 large-scale and high-quality systematic reviews. Most of them are from our own group, but yeah, 17 of them are from Cambridge reviews. And when we map this, we find that our students, on average, uh, correctly detect 75% of the relevant studies, meaning that they find 3 out of 4 relevant studies on average. The content experts or the researchers on average are a little higher. They have recalls around 83% on average. So it means that approximately they overlook 2 out of 10 relevant studies when they do single screen. Um, and based on that information, we have built this benchmark scheme saying that if you cannot in your test data set or somehow show that you can reach recalls above 75%, you should not use this approach. You should at least just use it as a third screener. You should still stay with the human double screen. And ideally, you should also see if you can sort of tweak the prompt so it gives you a better recall, at least above, I would say 80, then you're quite on par with the typical research screeners. And even if you get about 95, then you would really do a good work with the model. And then again, specificity is a little bit more challenging to make hard guidelines about because we cannot reject that having say that you know your recall is 1 and your specificity is 50. Yeah, but if you are screening 50,000 references, this would still halve the size of the number of references that you need to read. So again, the specificity is a little bit harder to sort of make hard guidelines for, but we just set this arbitrary guideline that you should strive to have a specificity above 80 or something, 80%. And then the Friends project is so easy to convince people, oh, it works, but it's also a very simple case. So um, uh, that was actually not what I was going to say. That I need to say why is benchmark scheming so all important because that's something I really think I should highlight. Benchmark scheming really guards against bad or biased screenings entering our reviews. Uh, and it really allows us to make context-specific assessments. I mean, I cannot tell you whether it works in your specific context, but with the benchmark, I can give you some general guidelines and say if you can live up to these benchmarks, I think you're good to go. I would gladly discuss whether these are the right benchmarks, but I think the benchmark scheme, the idea of having the benchmark scheme is all important also because we cannot control model development and this the benchmark scheme allows us to sort of monitor whether models can keep up performing the same way over time. um, and if we suddenly experience that tomorrow the model developed tomorrow works differently and it cannot live up to our benchmark, we can stop using it. So I really think this is the best way we have to sort of steer this, standardize the screening approach, and also avoid the wild west. Um, and then yeah, this was what I was about to say about the Friends review is very simple, so it's easy for me to convince you that it's good. But we in the paper also do some more extensive experiments where we really try it on what we would consider to be very complex reviews. It's a review about the effects about testing frequency on student achievement. It's very complex, and even in that case, we can make it work on par with human screeners, meaning that it reads recalls above these or around 80%, and it still shows high exclusion rates as well. We in the paper we recommend always going with the GPT-4. It's much better than GPT 3.5, but our newest results suggest that this GPT-4o mini is extremely good. Always try it out. It's 200 times cheaper than GPT-4, and it performs on par with GPT-4. And that's some new research I will add to the papers at some point. James, do I have time for limitations? Okay, good. Um, yeah, of course we have the limitations. Of course, the main argument against this is it's a black box model. We don't know how it's trained. We don't know what's going on inside. and this is not a bad excuse, but I just want to notice that most human screenings are also black box operation or represent black box operation. So it's not that I say that we should not strive to be transparent, but I'm just saying that in the current practice that we do with humans, we are also quite black boxes. And then it's an off-the-shelf method. And to be entirely honest with you, this is actually the main reason why we have been disk rejected in RSM, because there are some people that argue that we can never give a proof of concept because the model today is not the same as the model tomorrow. But again, that's why I so hardly think we should have the benchmark in play. And then it can be prompt sensitive. I need to say this, but I must also say I have twice now been able to make a perfect prompt in the first try. So unless I'm just perfect in writing prompts, I'm not sure that this is always the case. It seems to me that the GPT API models, it really catches very easily what our objectives are. And then of course this can have a potentially large environmental impact. It's a little bit difficult to fully assess, but I still want to mention this um, because the time you save from not using a screener in half a year, yeah, that's quite difficult to assess. And there's also a paper saying the opposite. But anyways, I think the advantages outweigh the limitations to many in many ways. I think I will leave them there and just say future research. I really think we should, of course, it could be good to test it with local models like Mistral. They share what are their models. You can download them, and that this would really freeze the efficacy of this approach. Also, really, in our research group, we combine this approach, the AI screener, together with other traditional automated screening tools. So, like we use it together with priority screening. So it could be like the first 20% of your Thailand abstract that you have put in a prioritized order, you could screen them with two humans and the AI screener, and then let the rest be screened by one human and the AI screen. So you can play a lot with this. And also a new thing coming in is that now we can fine tune models, and we have not even tried this out yet. But we know how to do it, and I will add some functionalities to ease this in the AI screener. But now we can actually fine tune GPT models to the specific review, and that might actually be a game changer. We don't know. And then I think it could be very good if we could implement this screening approach in you can say in standard review software like Meta Review or Epi Review or Covidence, etc., or have a Shiny app or something. So sorry for all this speaking. I think I'm a little late, but that was it for me.
Great, thank you very much. And we do have a good amount of time for questions still. Um, I saw a question. Jessica, 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 would you want to pose your question?
Yeah, so I was curious how many included you need to have. I worked on projects where we maybe
Yeah,
have
yeah, that's a
5,000
good question.
and
Yeah.
15 are
Mm.
included. Will that work with the
But
model?
yeah. That would, as me, yeah. There's many answers to that question. Because we have actually. So let me start from the beginning. We have tried actually just taking one relevant Thailand abstract, and then we just keep tweaking the prompt until it included that Thailand abstract. And when we then scaled up the screening, it really just turned out to be very good. So in that case, we actually that was a case about functional family therapy review. And in that case, we were able to actually make a good screening by just testing it on um,
Oh,
one relevant record. And but usually we test it on 10. Having 10 key, you can say key references, that in our experience has been enough. So if we can show that it can find at least 8 out of these 10, and when we scale it up, it seems to be the same. But again, how generalizable is this experience? I cannot say anything about it, but it seems to be agnostic to the number of relevant references that you have. That's at least my impression. Yeah, yeah.
Thank you.
And that's also very important to say. All decisions are independent, so it doesn't learn from its decisions. Everything is independent. It's not that it's building up its learning curve or anything. Yeah. So it's yeah, that's quite different from what we usually work with when we use the traditional automated tools. Yeah.
Question from Sarah.
Hi, Mikkel. Thanks so much for this great presentation. I was just curious
Well,
if you had tested using examples in the prompts and if that had helped improve performance. So
yeah,
example of what
yeah, yeah, yeah,
you
but that doesn't. This is so hard to say. Okay, let me try to explain. This
yeah.
is hard because the model changed. The GPT-4o Mini is extremely good at understanding multiple tasks. If you have asked me half a year ago, I would say probably it could be better. No, but half a year we tested this, giving it an example. But these models are trained models, so the more text you give them, the more confused they get. They really just need to get very concise information. Not every all these examples you don't need, but you could do this in the fine tuning, and that is something we haven't tried yet. So you could, if you have examples, you could give it when you fine tune a model, you need 10 examples. So you could actually build a model with these examples. So, but I haven't tried it out yet. I have tried out, but I haven't tested how good these models actually perform. But examples are not needed. The more concise you can make a prompt, the better. And back in time, have you asked me 2 months ago, I would also talk about multi-prompt screening. So instead of giving all your inclusion criteria to the same prompt, I would suggest that you sort of add one inclusion criteria to each prompt, you can say, and then make judgment across these. So if it says 1 to 5 out of my 6 prompts, for instance, we will include it. But the GPT-4o Mini seems to be very good at multitasking, you can say. But again, this is a way you can tweak it. If it doesn't work in your setting, you could fine tune it. You could try to do multi-prompt screening or prompt chaining, and that's also why I say it's flexible, because there's so many ways you can treat. Uh, if you put another example into the prompt, that would be my.
And Mohammed, that he's been exploring different AI APIs for screening, worked with Anthropic, which is the Claude AI, Gemini, and the OpenAI API, and found that the Anthropic and Gemini seem to be working better. I guess any comment on differences between these systems?
Mm,
Not sure.
no, no, build a package and we can use it or something. Because I mean, yeah, there might be better GPT models out there, and yeah, and my problem is time to do the
Yeah,
coding,
yeah,
really. But so I will. That's also why we have built it open source so people can. It's very easy. The way the codes are now, it's very easy to tweak it so it can work with other models.
I see.
If
Yep,
if they if they if they if you can use function calling, because function calling is something different. So if you read other research about this using GPT API models, they do not use function calling. And function calling is basically that you make a JSON function where you sort of force the response. So in this case, we have forced it to respond by 0, 1, and 0, 1.1, and that should make it more reliable. Actually,
mhm,
that's the basic idea. So if you can do that, if other models or if other firms have models with that can take function calls, you can easily tweak our code to work with that as well. Yeah.
I think we
I,
got time for time for one last question from Kristen. Kristen, do you want to pose your question?
Hi, yeah. So I have to sometimes turn to community organizations and their research. And so I was wondering if you've tried this process for maybe non-peer reviewed research that might not have a formal abstract.
But I think if we go through this, you have a lot of weird things. It's not only formal stuff in here, I would say. So yeah, yeah. I mean, we have great literature in our experiments. So yeah, and there's a lot of even it also takes other languages actually. So it's not really it's agnostic to the language that it gets also. So yeah. Um, so it's not that we have just tested it on very streamlined abstracts. There's a lot of different stuff in there. We generally recommend if there is not an abstract, take it out and just human screen it. But it actually seems to be all right to do only title screening. But yeah, our recommendation is just if there's no abstract, let humans assess the titles. But yeah, yeah, that was a little bit away off your question. Sorry.
No, that was helpful. Thank you.
Okay. No,
Yeah, we're right at time, so I'll call it there. Mikkel, thanks so much for sharing this. It's really, really intriguing to see, and I think you've perked a lot of people's interest in investigating these tools.
thank
We have one more seminar coming up next month. It's going to be on Friday, December 13th, with John Farron from the University of South Florida and his colleague Megan Kirby from the Glaser Children's Museum. They're going to be sharing work on meta-analysis of single case experimental designs. All the details are on our website as usual. We hope you can join us then. Thank you all for coming.